Yeah, go ahead.
Actually, bias and variance, how to explain that is, and I want to discuss here. Could you
Yeah,
discuss that here?
yeah. You
Bias and
have you have any specific doubts or
concepts. How to explain that?
how to express how to explain bias and variance, right?
Variance.
Okay. See, when you are given a problem in machine learning, then you are given the task of like you are given a, so the first thing is you learn from the training data. So you learn from certain amount of data which is given to you, and that is known as the training data, and certain amount of data is not given to you, and you are expected to perform well on that data after you have trained your model. So that is known as the testing data, correct? This is the normal paradigm of supervised machine learning. Now when you are training on your data, let's say you are not being able to model your training data itself properly, like your training loss is very high, training accuracy is very low. In that case, we call that system to be a high biased a low bias system. Okay. So so that means that I am not being able to train on the training data itself. That means that you are, and why it is called bias, somebody told this when I was talking about this in the first class, that you are so biased that even after seeing the training data you are not learning anything. So that is why this problem is known as high bias, this problem is known as a high bias system. Okay. um, oh sorry, I'm mixing up stuff. So this is known as a low bias system, when you are not learning anything from the data, and when you are learning everything, and when you are training your model, and your model is learning, uh, your model is learning everything that is given, everything that is there in the training data, such that when you are given a new test data you are not being able to generalize well to the test set, then that system is known as a high variance system, and that system is known as a high variance system and a low bias system. Okay. I have confused you more than you were before probably. So let me open the first week lecture and give you some examples. Okay, what is visible to you? Yeah, this is visible, right? Okay, people are continuing to join. Oh, okay. Where under fitting zone. Okay. Yeah, you can see this curve on my screen, right?
Yes, I can see.
Yeah, if you see here, okay, some people are joining. Let me admit them and then I'll go back to the slide. Okay, yeah. Okay, yeah. Again, people are, that is why. Yeah, so if you see here, so the model, so underfitting means when you are not learning enough on your training data. Yeah, underfitting means actually high bias. I was confusing that. Okay, so yeah, so let's say when will I call you highly biased? So you can unmute yourself and we can talk actually. So who asked the question?
Here I am,
Yeah,
Sandeep.
yeah. So when do I call you highly biased? When I am giving you something to learn, but you are so biased that even after I am giving you something to learn, you are not learning anything from that. At that point of time, I will call you highly biased. Am I correct?
Yes, okay.
So when your model is not learning anything from the training data itself, you call that to be a high bias case. Okay, I was confusing that with low bias, but that is actually high bias. So high bias means when you are so biased that you are not learning anything from the training data, and that is known as underfitting. And in this case what you need to do is you need to increase your model complexity so that your model starts to learn from the training data, because unless you start learning from the training data you cannot hope to perform well on the test data again. And the other case is when you have very low bias, which means that whatever I am giving you, you are just so basically it's like you are learning by heart everything that is there in the training data, and in that case your model bias will go down, but when you are given an unseen question during test time, you won't be able to answer well because you have memorized everything that is there in the training data. That is known as a high variance case, and in that case, in order to remove high variance, you need to reduce the model complexity so that you don't memorize everything that is there in the training data. Am I clear, or should I explain it a bit more?
Actually, how to explain the term variance? What is variance?
Yeah, so the variance is the term that is given to this case, like okay, yeah, so variance you can explain it like suppose your model, how can I say this without showing a diagram? Let me see. Okay, here it is not there. Okay, yeah, so variance you can say like high variance in this case means let me see of any diagram which I can find. No, it is not there. Okay, how can I show you? So so basically this is called high variance because this is like so you are fitting so closely to the training data that if you have so I need to show you a diagram actually. Without that, explaining this would be difficult. Let me try to show you a diagram. Maybe that would be helpful. Okay. High variance classification, maybe high variance classification.
Sir, if we have to say that if suppose our model is having low bias,
Yeah,
that means that it is working well, extremely well on training data,
yeah,
that it's working. But when we give it unseen data, that is the test data or validation data,
yeah,
it fails completely.
yes.
And when we say it's a high bias, that means that we are, out of the training data as well, it is not taking all the data points. It is, taking very less out of it, and it is leaving out many of the data points because of the restrictions that we have added. Is that right?
Not I mean, what do you mean by leaving out data points? You are not leaving out data points.
In the sense, like we have got 10 fields or 10 features in our
Yes,
table, out
yes.
of which we are only taking 4. So we are leaving out 6.
No, I mean it will be like you are taking all the features that are given to you, but your model is so light that it can't handle 10 features. It's not
Okay.
like you will leave out 6 features and train only on 4 features. You will
Okay.
train on the 10 features, but your model will ignore the 6 features and will work only on the 4 features maybe. In which case it will not be able to give you a good training accuracy also. In that
Okay.
case you will be considered to be a high bias system.
So
I
we
mean,
are giving input all 10 features, but it is working on the 4 in a
yeah,
poor
I mean
condition.
you don't know how many features it will work on. The model is light that it won't, probably it is taking all 10 features, but it is not being able to learn how the 10 features should be combined with each other to give you the correct result. That
Okay.
might also be a problem. Okay. Yeah. Yeah, just give me a minute. I'm trying to find out a proper diagram for this. Somebody is trying to enter. Okay. Okay. See, one simple way which I can explain this is like if you overfit on the training data, then depending on your test data, your prediction can vary a lot. Okay, and because of that, you might think that this is called you might understand that this is the reason why it is called high variance, because if your testing data point is very close to the training data point, then it might vary a lot. That is so depending on your test data point, there might be a lot of variance in what you predict for your predict by means of your machine learning model. That is one explanation why it is called high variance, when your testing error is high and your training data is less. Okay, let me try to share this. I don't know. Okay.
Soumya,
Yeah.
what I suggest, we will discuss this concept in the coming session, and you can discontinue with the current problem now, because unnecessary time will go waste, right?
No, I will just show you one diagram. Maybe if you are not clear with this, then I'll pick this up in a separate thread next week. Okay.
Yes,
Let
yes, it's absolutely fine.
Yeah.
Perhaps maybe you can also share the inputs in the discussion forum. Everybody will get the notification and
Yeah. Can you see this diagram which is there on the screen? You will find this sort of diagram in Google just like that.
Yes, overfitting. We know
You
it.
can
Yes.
see this left diagram, right? So if you see here, so the leftmost curve which is overfitting, so if there is a if there is a network which, I mean, if there is a test point which is very close, so if you can see my cursor, so can you see my cursor or is it not visible?
Yes, yes, yes. I
Yeah,
can see.
yeah. If suppose there is a testing point which is very close to the topmost point here. Okay, you got the idea, right? I mean, suppose there is a testing
Yes.
point which is just below this particular point.
From this diagram, what I can interpret that
Yeah.
whatever comes to the machine, it detects it as a valid pattern. Actually, that is means it is showing that that is a valid test point.
Yeah, so basically what will happen is, if you give it a test point which is very close to the topmost point in this particular curve, okay, it will try to predict it by means of,
So
it will
it
be
will show you true positive.
uh, okay, let me stop this for now. I'll start this in the next lecture. You remind me. I'll create one or two slides about overfitting, and I'll give you some examples, because this is not this is actually regression. I wanted you to show something regarding actually classification, because that would be clearer.
Yes, yes, that would help us, and the
Yeah,
term
yeah.
variance will be
The
helpful.
term variance is there because actually what you can do is, basically the term variance comes from the error that you find in any problem. You can break that up into two parts. One part is due to bias, the other part is due to variance. So from there the variance comes. It basically is just that error term basically means that comes out to be the variance, like e minus the mean of x minus the mean of x. So basically because of that this is called variance, but I would try to give you a more intuitive explanation as to why this is called a variance. I'll probably search for some diagrams and I'll show you that. Okay,
Yes,
maybe
absolutely fine.
yeah,
So
that
no
would
worries.
be better maybe. I don't know
Yes.
whether this diagram is correct or not. Okay, I'll this is a high bias system anyway. Okay, I'll show you this maybe next class. The first thing I'll do is I'll show you the next class. Okay,
I would remind you in that
yeah,
case.
sure,
Yes.
sure,
Yes.
sure. Okay. Let me again share the screen. Have to do this. Okay. Yeah, so today I saw that in the last week the main lecture was about naive Bayes. So naive Bayes classifier and some basics of probability, and I have not seen the assignment for this week, but mostly the assignment is should be relating the some basic probability problems. So as instructed by this NPTEL people, that I'll work out some problems today on probability. So that is why I asked you to keep a copy in front of you. Okay, so these will be pretty basic concepts of probability. So I'll ask you, I hope this session would be interactive. So I'll ask you in between, and if you have any doubts you can always stop me and ask me. Okay, so my screen, I mean whatever is written there, is it visible or should I read it out?
Yes, it is visible, and you can read. You can read. You can
Yeah,
read
so
also.
basically the first question is so you have a spam filtering
Sir,
system.
actually, this was covered in yesterday's tutorial.
Yeah, I know, I mean that is what the NPTEL people has asked us to do, that we have to cover the similar problems in multiple sessions. I don't know why, but that has been the direction to all of us. Okay,
Okay, no problem.
so that is why we might, I mean there will be a lot of overlap between all our sessions. Okay, so yeah, so the question is I mean did everybody attend yesterday's session, or else I will just
No,
skip?
no, didn't attend.
No, sir. No,
Okay,
we can continue.
okay,
No.
okay,
We have not attended it, sir.
okay, then I'll continue with this problem. Somebody is entering. Okay, yeah, so we have a spam filtering system. So it has the probability of 95, so 95% of the cases it is able to correctly classify a mail as spam, and 10% cases it will give a false positive. A false positive means the mail was not a spam, but in spite of that your filtering system is classifying that as spam. And so it is estimated that in the mailbox whatever you have, there are 1% of the mails are actual spam mails, and so 1% are spam mails, 99% are non-spam mails, that is given. And so suppose you get a new mail, and what is the probability that the mail will be classified as spam? So this is the problem. I have the solution in the next slide. So anybody wants to give it a try who has not seen this problem yesterday? So can you just say what should be the approach? I am not asking for the answer, what should be the approach about to go about this problem?
We should be first noting down the probability of spam versus probability of not spam, and individual means before any conditions are there.
Okay.
And then we should find out if suppose email like um,
Yeah, so let's I'll go with you. So first you said that we need to find out the probability of the mail being spam or not spam. So what is the probability of the mail being spam?
okay,
10% probability.
Probability of being spam is 0.95.
See, the question is the spam filtering system has a probability of 0.95 to correctly classify a mail as spam, and 10% probability of giving false positives. but the male, it is estimated that 1% of the males are actual spam males. So in the
Yes.
mailbox, when you get a mail, what is the probability that the mail will be a spam mail? So there are two things here. First, the mail can either be spam or not spam, and irrespective of that, your spam filtering system will work on it. So what is the probability that the mail itself is spam in this case? So
1%.
1% chance. So 99% chances the mail is not spam, correct?
Yes, sir.
So once it is spam, then the filtering system will mark it as mark it correctly as spam mail in 95% of the cases, right?
Yes, sir.
And even if it is not spam, then it will mark it as a spam mail in 10% of the cases. So that is there in the problem. So I'll just give you the solution here. See, the first probability is the probability of, just a minute, somebody is, okay, yeah. So the probability of the mail being spam and marked spam, that's the first probability, that is 95%, that is given here. The probability of the mail being spam and marked not spam is 1 minus 0.95, which is 0.05. So, and similarly you will get, if it is not spam mail, then even if it is not spam mail, it will be marked spam in 10% cases, 10% of the cases, because the false positive rate is 10%, and even if it is not spam, it will be marked as not spam in 90% of the cases. And in the mailbox you have a total of 1% of mails which are coming in as spam mails, and not spam is 99% of the cases. So basically, as somebody said, it's like the total number of the probability of the spam mails into the marked spam. So the p spam means the mail itself is spam, and once it's spam, what is the probability of it being marked correctly, and similarly it being not spam but being marked incorrectly as spam. So once you multiply, you will get the answer as 0.1085, which is option C. Okay, so anybody has any doubts? This is a pretty simple problem. Anybody has any doubts with this?
Sir, once more, please explain, sir. Last steps.
Yeah, so let's say you have got so your question is, when a new mail comes, what is the probability that your spam filtering system will mark it correctly as will mark it as spam? That is the question that you are asking. Suppose that the
Yes.
system is now given a new mail to be classified as spam or not spam. What is the probability that the mail is classified as spam? So that is the question. So the first thing that you need to do here is, you need to understand out of how many mails, out of the I mean, once the mail has come, what is the probability of that mail being actually spam? So that is your
Yes.
piece, that is given by p spam, correct?
Yes, sir.
And once it's spam, it will be corrected, it will be correctly classified as spam email by
Yes.
this probability p of marked spam given spam. Okay,
Okay, sir.
so that is 0.01 into 0.95. But in 99% of the cases, the mail will not be spam, but but because of the false positive rate, the mail, your filtering system will classify it as spam, and therefore you add these two up and get 0.1085. Okay.
Oh, okay, sir.
Okay, so I'll go to the, these are, I know these are very basic problems, but I have to cover them. So the next problem is, bag 1 contains 4 white and 6 black balls, and bag 2 contains 4 white and 3 black balls, and one ball is drawn at random from one of the bags and it is found to be black. Find the probability that it was drawn from bag 1. So can, again, like the last problem, can somebody say how to go about this problem? Anybody?
Black balls.
I'm
Hello,
not.
sir.
Yeah.
Sir, actually, yesterday we have done the same problem and the answer was 0.10425 and today is different. So what is the correct answer between both?
Which one? This problem?
No, sir, first question.
First question.
No, ma'am. Yesterday we have got the same answer. Point 104. 104. It is 8. It is not 85. So it is 104.
So
Yes,
previously
it was
probability of spam was 0.5%. Now it is 1%. So there is
exactly.
yeah, that's why difference is coming.
Previously probability was 5%.
Answer was B,
Zero.
sir. Here, Soumya. The answer given was B. Yesterday, the same problem was solved. No?
uh, I am pretty sure. What is that? Somebody said 5%, right?
Yeah, so previously the probability of spam was, I mean, on previous day it was 0.5%, but today it is, I think, 1%. So
Or
that's
maybe
why,
because of that it
yeah,
is
so
coming.
difference in answer is coming.
Okay, yeah, but this is correct, I can assure you that. If you, I mean, if you work with which one was 5%, it is estimated that 5% of the mails are actual spam mails, is
Point
it?
five. It was 0.5%.
0.5, yeah.
Yeah.
Okay, so let me calculate
Yeah.
again.
This is correct, sir. This is proper.
This is fine.
Yeah, okay, yeah, because yeah, so it is estimated that, yeah, so you should look at the, rather than looking at the answers, you should look at the numbers properly. So
Got it, sir. Thank
yes,
you.
yeah, okay. So yeah, as I was coming to this problem, so this can somebody, can anybody, did all of you work on this problem yesterday also, or is this new?
This is new. This is new.
Okay, okay, at least I'm happy to know that. But yeah, so can somebody say how to go about doing this problem? Okay, so let me,
Yeah, so
yeah,
answer would be C, maybe total favorable condition upon total conditions. So if drawn from black bag 1, then it would be favorable would be 6 by 10. Then total would be from black from bag 1 and black from bag 2. So it will be 6 by 10 plus 3 by 7. So it will come, I think, as C.
Plus or multiplication? 6 by 10 into 3 by 7, I think.
We are drawing one ball, right? So plus would be, I mean, denominator would be all the conditions, so those would be summation, not product, I think.
okay, so yeah, clearly one of you is correct. Okay, so let me show, I mean, how to go about this problem is, see, bag 1 has 4 white and 6 black balls, and so what is the probability that when you choose, so the question that you have is, one ball is drawn at random and it is found to be black. So this is your event in this case, that you have drawn one ball and it turns out to be black. So that is given to you. So suppose you chose bag 1 in the first place, then what is the probability of that ball being black? It's nothing but 6 by 6 plus 4, which is 6 by 10, which is 3 by 5. Okay, similarly, if you chose bag 2 in the first instance, then you would have the probability of picking out a black ball is 3 by 3 plus 4, which is 3 by 7. Now what has been asked from you, you have been asked to find the probability that it was drawn from bag 1. Given that you have the ball that you have drawn is black, what is the probability that you drew it from bag 1? That is the question that we have been asked. So basically it's like probability of bag 1 given black. So that is the probability that you need to find out. And from Bayes rule, if you just write out Bayes rule normally, it will be like probability of black given bag 1 into probability of bag 1 divided by probability of black given bag 1 into P of bag 1 plus P of black given bag 2 into P of bag 2. So if you do these calculations, it will come out to be 7 by 12, as somebody said, it's option C. So somebody was saying about multiplication. Do you have any doubts about this? This is just plain application of Bayes rule. Hello.
No doubt, Soumya.
Okay, so yeah, so no doubt means I can go on to the next problem.
So can you explain denominator?
Yeah, so this is normal Bayes rule. So basically what you can um, so this is, so you know how so let's say you have P of, don't consider bag 1 and bag black, consider P of A given B. So probability of A given B is probability of A intersection B by probability of B, right?
Right.
So if
Right.
you break out B in terms of the total probability rule, then you will get this particular expression. That's it. It's simple. So in this case, how you can explain this? So probability of bag 1 given black, you can write it as probability of bag 1 intersection black divided by probability of black, right?
Yes, this is elaborated version of Bayes rule
This
actually.
is the elongated version of Bayes rule. So so probability of bag 1 intersection black, you can write as probability of black given bag 1 into probability of bag 1, that is the numerator. And the denominator you can write similarly, like so numerator you can write probability of black given black intersection bag 2 plus probability of black intersection bag 1, and you can break each of the two summations in this way. So that is why you get this particular expression. This is just normal application of Bayes rule, the elongated version of Bayes rule, as somebody said. Okay. Am I clear?
Yes.
Yeah.
Formula is pretty simple because it is elongated version, no? So we have to put the values only.
That is, I mean, so Bayes rule I prefer writing it in this way, because this way also it's like finally you just have to put values and you will get the answer. So
Sir,
that,
I think we can think in such a manner that all types of probability should be taken in the denominator. So if we are taking from either of the bags, and in the numerator what we have asked for, only we have to take for that probability.
correct. Yeah, you can think of this in that way also.
Yes, sir.
So that is not an issue. You can interpret Bayes rule in your own way. So
Okay, sir.
okay. Okay, so what is the third question? Yeah, third question also it can be common, because actually these are all taken from the assignments that were given in the last run of this particular course, and we have been asked to cover those questions. So that is why there will be some common threads between our presentations.
Sir, some of us we are not present in that session.
Okay.
So
Okay.
please give a brief explanation so that we can understand it better.
Yeah. So these are the, I mean, just a minute. Yeah, so these are the problems. I just wanted it because these are not very difficult problems. So that's why I am asking all of you to to think out aloud in the beginning, and then I will give you the solution anyway. So, okay, so in this case you have two nodes F and C. So F is flu and C is cuff. Okay, F is you have the flu and C is scuffing. So provided, I mean, so the arrow is from F to C, which means that given that you have the flu, what is the probability of you coughing? That is given by 0.8, and even if you don't have the flu, you have a probability of coughing as 0.3. So these are given by the two conditional probabilities on the right, and the probability of you having a flu in the first place itself is 0.1. So so the question is find PC and P of F by C, which means that probability of coughing and probability of flu given that you are coughing. So let's so these are again very simple applications of probability rules and all. So what is the probability of you having a cough? Can somebody, these will be simple calculations, so can somebody say probability of you coughing? What is the probability of that?
We can add the product of the probability of flu and probability of coughing when flu is there,
Yes.
with the probability of coughing when flu is not there,
Yeah.
and we can add both of them.
Yeah, you are, I think you are correct, you just missed a small part. So this, I think this is what you meant, right? Probability
Yes,
of you having a cough is same as
yes,
probability of cough when you have a
yes,
flu into the probability. So this is again just the formula of total probability. So basically what you can do is, what you can think of like is P of C is equal to P of C comma, which is P of C intersection F, plus P of C intersection F bar, and you break up each of this sum in this way. The two sums that you
okay,
have, you break up in this way. Okay, P of
okay,
C, this is P, the first summation is nothing but P of C intersection F, the second summation is P of C intersection F bar, and you just add them two up, add those two up, and you get 0.35. And somebody was asking that how the denominator of the Bayes rule comes. So this is an example. So here you need to find probability of flu given cough. So probability of flu given cough, the numerator is probability of F intersection C, which you can also write in this way: probability of cough intersection F into probability of F. So this is the way you can write in the numerator, and the denominator is P of C, and P of C I have already found out in the first example as this. So you just write them and you will get this value. So this option is 0.35 and 0.23. Anybody has any doubts in this? This is just an same problem from the last example, basically. Just a fancy diagram is given.
We can do this like this step also, right? Probability of flu given cough plus probability of flu given cough equal to 1, and then substitute the values. That will be okay, right?
I did not get. Can you come again?
We can also do it like this: probability of F given C plus probability of bar given C is equals to 1, and then substitute the values. That will be fine, right?
That should be fine, yes. But you are not using that anywhere, right?
Okay.
You are, I mean, F bar given C also, F bar given C is also not given to you. So
But we can convert C given F bar to that.
that would be, I think for me that would be a lot more work. This would be easier because this is a simple application of Bayes rule. So so I would prefer this way of solving this problem.
Okay.
Okay.
So-
Okay. Yeah.
Soumya sir, in this one, when you say PC equals to PC given F, PF plus this,
Yeah.
this is true if like it is a base network where like F is pointing to C, I mean C is driven by F, or is it true for two independent variables also?
See, I am not talking about independent variables, because independent variables P of C comma F is nothing, is equal to the product of the two probabilities. Okay, and if you are conditioning on F, if C and F are independent, then P of C given F is just P of C. Okay, you are not getting any extra information when you are conditioning on F. Okay, so this is true for this particular network. Of course this formula will hold, but then C of C given F will be something else. In that case, P of C given F will be P of C only, and P of C given F bar will be P of C only.
Got it, sir.
Yeah. Okay. Okay, so coming to the next problem, coming to the next problem is this is a bit hazy. Okay, so we have a Bayesian network. So we have 5 nodes now, and A points to C and C points to E. A also points to D and B also points to D. So the independence is expressed in this Bayesian net such that A and B are independent. A and B are completely independent of each other, and C is independent of B given A, because if you see here that once A is given to you, then you don't need to depend on anybody else to understand about C, because A directly points to C and nobody else points to C. D is independent of C given A and B, because again D has only two incoming edges from A and B, and E is independent of all the other nodes if you just give C. Okay, so these are the independence relations that are given in this particular problem. So there are all the probabilities, there are several probabilities mentioned here. So the question is find PD. So I don't want you to give the values, but like we have already discussed how to find out. So from what we have already discussed today from the previous problems, how should we go about finding PD? So not values, just tell me the gist of about how should we go about finding PD. One hint is it will again come from the total probability rule.
So could you please explain what is Bayesian network and all?
Yeah, so Bayesian network
I'm
is
missing on the fundamental.
Yeah, Bayesian network is just like this. Like you have a number of nodes, and you will show the relations between the different nodes by means of these arrows, and these nodes will individually have probabilities assigned with them, and so that is in short a brief description of a Bayesian network. So so that is it. There is nothing more to it. It's just like there will be a number of nodes interconnected with each other, and there will be so in this case D, the occurrence of D depends on the occurrence of A and B, which is why you see two arrows from A and B coming into D. Similarly, the occurrence of C depends on A, therefore there is a arrow from A to D, A to C, similarly C to E, which means that once you have the value, once you know that A has occurred, you know with how much probability C might occur or might not occur. Then that is why C is said to be conditionally independent of all other variables if only A is given. Okay, did you understand what I said? Or
Yes.
Yeah, okay, so then I should what I should do is I should go about the probabilities also. Maybe that would make it clearer to you. Okay, see, the first thing that are given, the first two things which are given is P of A and P of B. They are visible, right? I know they are hazy, but you can still see them, right? Or should I zoom
It is
in?
readable. It is legible.
Okay, I should zoom in maybe slightly. Oh no, yeah. See, the first thing is P of A is 0.3 and P of B is 0.6. Why? Because A and B are independent. They are the root nodes of this, if you can call them. They are the root nodes of this network. A and B don't have any incoming edges, they only have outgoing edges. So they will occur with some probability. That probability is given to you. P of A and P of B, the root node probabilities are given to you. The other thing which is said is C is independent of all other variables only if A is given. So if A is given, you know everything about C. So P of C given A bar and P of C given A is given to you. P of C given A is given and P of C given A bar is given, which means that if A occurs, then the probability of C occurring is 0.8 and the probability of C not occurring even if A occurs is 0.2. Similarly, if A does not occur, then C occurs in 40% cases and C does not occur in 60% cases. That is the way you interpret this, you relate these probabilities to this particular arrow which is given in the Bayesian net. The other thing is probability of D given A comma B, which means that if A and B both occur, then the probability of D occurring is 0.7. The next, and similarly if so the next probability is if A occurs but B does not occur, then the probability of D occurring is 0.8. The probability of the probability of D occurring when A is not occurring and B is occurring is 0.1, and when A and B are both not are occurring, then probability of D occurring is 0.2. Similarly, like C was conditioned on A, you have been given the probability of E given C and E given C bar, because E is conditionally independent of A, B and D if C is given. Okay, so is it clear now, or should I go about it once more?
Clear, sir.
Okay, so now can anybody say how to find out PD? So what's the first step that you need to do in order to understand PD? I mean, in order to find out PD, the probability of D occurring. So first, somebody tell me what are the two, three, four variables that on which the occurrence of D is dependent.
A and B.
A and B.
A and B.
Correct. Okay, so in the total probability rule, what will you so in the total probability rule, what should you use along with D in order to find out the probability of D occurring?
Probability of D occurring given A,
B and B.
and probability of D occurring given B.
Probability C, what you have said,
D is
uh,
independent.
D is independent of C given A and B. Okay, which means
Yes.
that you have to consider A and B together. You cannot
Yes.
separate out A and B when you are talking about D, because you see there are two arrows which are coming into D from both A and B. So that is the first.
We have to consider all the probabilities containing A and B.
Which probability? So in the different probabilities that have been mentioned in this, which probability should you consider?
Those probabilities which contains A and B.
So this
0.7.
one,
Probability
A,
of A, probability of A, and probability of B.
probability of D given AB.
AB.
Yes, sir. Yes, sir. Probability of D given
0.7.
AB.
That is the only probability that you would consider, is it?
No, I think all of them should be considered.
See, when you are saying that you are considering probability of D given A and B, you are only considering the case when D occurs when both A and B is occurring.
0.3,
Okay.
Probability of D
1.1,
containing A bar, B bar.
Then why should you not consider probability of D given A comma B bar? See, the intuition behind this is you are trying to find out when D is occurring. So you need to find out all cases in your particular Bayesian net where D can occur. So you know that D occurs in all these four cases, probability, that's 0.7, 0.8, 0.1 and 0.2. So you need to consider all of them when you are considering the probability of D, when you are considering the probability of D occurring. Am I clear?
Yes, sir.
Okay. All scenarios are getting what, just to understand, like
Yeah.
if suppose there is A and B both probability of D occurring given that A and B are both occurring, given
Yes.
that A is not occurring, B is occurring, given that B is occurring, A is not occurring,
Yes.
and both A and B are not occurring, right?
Correct.
These are
Correct.
the four cases.
Yes, because your aim
All the
is
four
to
probabilities.
all the four probabilities you need to take account for, so that you don't miss out on any cases when D can occur, because D can occur in four possible cases as you have seen here. Okay, so but the other thing is you need to find out the probability of D. So what you need to do is you need to multiply probability of D given A comma B into probability of A comma B. Am I correct?
Yes, sir.
Okay, so so finally it will come down. Why is it not going? Okay, got it. Yeah, so finally this is the probability that you need to do. So probability of D given A comma B into probability of A comma B plus probability of D given A bar comma B bar into probability of A bar into A bar comma B, probability of D bar given A comma B bar into probability of A comma B bar was probability of this final thing. Am I clear? This first step is clear to all of you, or there are doubts?
So now A and B are independent. So
Yeah, so
if
that is
they
the
are-
next step. That is the next step. I am saying that up till, I mean, this particular expression is clear to you, right?
Okay. Yes.
See, See, the thing is, you are just looking at this from a different perspective. In this case, you have done the same thing. Like probability of C, you have done the same thing here. So you are doing the same thing with this particular, here there are just two variables, which is why it is slightly more complex, but basically it's the same thing. Okay, so you have this four probabilities. Now you need to find out probability of a comma b, probability of a bar comma b, probability of a comma b bar, and probability of a bar comma b bar. So as somebody said, a and b are independent, so the joint probability of them, or the so p of a comma b will become p of a into p of b, p of a into p of b. And since a and b are independent, a and b bar will be independent, a bar and b will be independent, and a bar and b bar will also be independent. So you just multiply these probabilities. P of a will be p of a was 0.3 if you see here, and p of b was 0.6. So you just multiply 0.7 into 0.3, 0.6. This case p of a bar will be 1 minus 0.3, which is 0.7, and p of b is 0.6. P of b bar is 0.4, and the last case is 0.7 into 0.4, and you will get this answer to be 0.32. So that is the answer for this. So the answer doesn't matter. This first step is the one which I want you all to understand. And of course, since it is independent, so this p of a comma b will break down into p of a into p of b. So these are the two steps that are important in this problem, and then the problem is just calculation. So there is nothing more to it. Okay, so yeah, so
Okay, sir.
okay, yeah. So after this, there is the okay. So there are just two more questions, and so consider the following graphical model. So
Sir,
yeah,
just one thing wanted to ask.
yeah,
Like in the last example, we
yeah.
had one node with two parents.
One node
Suppose
with two parents, correct? Yeah.
suppose in the exam, if the number of parents tend to increase, then not means the approach remains the same.
The
It's just the
approach,
number of cases will increase, right?
yes, approach will remain the same. Approach will always remain the same. The calculations will, but I don't think they will give you anyway. I don't know. I mean, maximum 3 they can give. More than that, I don't think they will give, because it will be a lot of calculations.
Okay.
So, but
One more question here.
yeah,
In the same diagram, if suppose we have to calculate b when b is not given, for example, in the
B is not given.
probability of b is not mentioned, we have to try and found the probability of b.
Yeah, if your root probability is not mentioned, then then p of d must be given to you, and p of d given b must be given. P of d given a comma b, if the p of d must be given in that case. Otherwise, it won't be. I don't think it will be possible to find out pb, because it's a root node. So if it is not given to you, then you won't be able to find p of d in this case.
Okay, actually there is a similar question in the assignment also, sir, wherein like probability of sprinkle is to be find out, and that is the root node.
Okay, so I'll give you one example today itself. So let's see if it. One more thing is, I did this in the first few lectures. In the first two lectures I did this. Like, I discussed some questions which are there in the assignment this time. Okay, so they have sent me a mail that I can't do that. So I won't be able to discuss any questions which is there in this assignment.
Sure, sir.
Okay.
You can talk about root one. That is okay.
Yeah, root 1, I will give you an example where you won't be able to find out the probability of one particular, in one particular case you won't be able to find out the node, I mean the probability. So I will give you that example. You can extend that to the assignment problem that you are referring to. Okay.
Sure.
Yeah, so in this case, we are considering the following graphical model, in which these are the dependencies. Which of the following pair of random variables are independent? Consider the following graphical model. Mark which of the following pair of random variables are independent when there is no evidence given. So you have not got any evidence, like none of the probabilities are given to you. Which are the independent set of variables?
A and B.
Okay, Okay, so yeah, that is correct. But why is C and D not independent?
They are dependent on A and B. That's why. D is dependent on B.
And C?
C is dependent on A and B.
Yeah, so because of B, C and D cannot be independent. Okay.
Sir, A doesn't have any role in independence of C and D, right?
A doesn't have any role on independent, because if you C and D are conditionally independent given B.
Okay.
Once you say once you tell about B, then C and D will become independent of each other. Okay.
Okay.
Similarly, what is the issue with E and D?
E is dependent on C. D is dependent on B.
And C and D are not independent of each other. Therefore, E and D are not independent of each other. So basically, it's the problem with the B node itself. B is dependent on D is dependent on B, C is dependent on B, and E is dependent on C, and in turn on dependent on B, which is why E and D are not independent of each other. Okay, so that is one. And why and C and E are not independent, I think it's pretty clear, because there is a direct arrow between them, so they can't be independent of each other. Okay. Any doubts?
C and D are not independent because they are connected to variable B.
B, correct, correct. Okay, so coming to the last question. So as somebody, I have already given out the answer for this in a way. So it is given that P of A by B is A given B is 2 by 3 and A given B bar is 1 by 3. So what is the probability of B given A? Can somebody try to find out what is B given A? What formula would you use? That's the base rule, correct? So if you break up base rule, what do you get in the numerator?
P probability of A by B into probability of B divided by probability of A.
Yes. So can you find out probability? Can you find out the numerator? Denominator we'll talk about later. Can you find the numerator?
Numerator, there is probability of B also required, which we have to calculate.
Yeah. So can you calculate probability of B?
Yeah, the product rule that you showed in previous slides looks like.
Yeah. Can you try that?
Yeah, sure.
Yeah. Just give me a minute. I'll be back. Yeah. What is the probability of B in by means of the product rule or the total probability rule, whatever?
So ideally, it should be probability of B given A into PA plus probability of B given not A into P not A.
Correct. And you are supposed to find probability of B given A, for which you are trying to find PB, and in trying to find PB you are coming back to trying to find probability of B given A.
Yeah.
So this is an example where you can't find probability of B given A because you are not given the probability of PB.
Yeah, not possible.
Okay, so this is one example where you are not where it is not possible for you to find P of B, probability of P given A, because you are not able to find probability of B.
Sir, what will be the probability of B bar? Will it be 1 minus PB or different?
Probability of B bar. You don't know probability of B, right?
Yeah, so I was doing this probability of A is equal to probability A given B into PB plus A given B bar into B bar. I
Huh?
was doing this.
Yeah, yeah. So
So
probability of B bar will again be 1 minus PB.
1 minus PB.
Yes, it will always be 1 minus PB.
Soumya, how would I find the probability of A in the denominator?
Probability of A
Probability
in
of
the
A.
probability of A in the denominator, that also you won't be able to find, I guess. I mean, I have not tried that. uh, Probability of A given B is there. If you are not given probability of B, then I don't think it is possible to find probability of A.
That's correct, sir. Because there will also the formula will be probability of A given B into probability of B.
Yeah, yeah.
So the
Once,
probability
because so basically this is the example where see, if you see the all the examples that I talked about today, see here it is like F is B and C is A. So that is the problem that that you can refer to. You see, in trying to find PC, you had required you required PF and PF bar. If this is not given, so if this is your Bayesian net and you are not given the thing that is causing your Bayesian net to function, then it is either this or either PF or PC should be given. Otherwise, it is not possible to find the probability of both of them. That is not possible to find in such a case. Okay.
So this is the best tip we have got today. Wonderful.
Yeah, okay, so this is one example. I don't know whether it will directly correspond to the what you talked about before in the assignment, but this is one. I mean, there are certain cases where so your parent node, if it is not given, then it is difficult to, or either parent or child node is neither is given, then it is not possible to find out any one of them also. Okay, so that is one observation that it comes out from this very simple example.
Hello, sir.
Yeah.
Actually, sir, I have a question in my mind. In question number 4, we have to find probability of D. And according to Bayes' theorem, we have not used anything in denominator. So please explain me that.
No, Bayes theorem will be so Bayes theorem will be, you can use it in this sort of cases. Okay, like
Probability of D.
see here you will use Bayes theorem because P of C given F is given. So it's like what is given to you is you have flu. What is the probability of you having cough? That is given to you. Now with this information, if you want to find out if you have cough, what is the probability of you having flu, then you will use Bayes theorem. So if you are given P of A given B, when you are trying to find out P of B given A, then you will use Bayes theorem. Otherwise you will just use normal probability, total probability rules. Okay. Here you are trying to find P of D, which is not a conditional probability. So that is why you are already given the conditional probabilities here. You just used the total probability rule for finding out PD. You are not looking at Bayes rule. You don't need to look at Bayes rule in this particular case, because you are not trying to find out a conditional probability in the, I mean, you are just trying to find out P of D, not any conditional probability.
Thank you, sir.
Okay. Okay, so yeah, so that is the end of today's lecture. Anybody has any questions? I will talk about bias and variance in the next lecture. The first 5-10 minutes I will try to find out some diagrams, and then I will go on with the next part of the lecture, what is there in the next week.
Sir,
And
I
sir,
have
can
one
you
question.
explain?
In the first question, there is a question in the previous last thing, that what is the probability of misclassification of mail? So how to calculate it?
What
In
is
the
the
very first question that you had shown, the spam filtering one, first question,
okay,
there is a question about the probability of mail misclassification.
where what is the probability that the mail is classified as spam?
No,
Yeah,
no, mail is misclassified.
misclassified as spam.
It was written as misclassified, so I don't know what is there. So the question was, what is the probability that the mail is misclassified?
Okay, so the mail is misclassified means you have to consider two cases. The mail is spam, but you are incorrectly classifying that as
Not spam
non-spam,
and
and the
yeah.
other case that the mail is not spam, but you are classifying it as spam.
So
So you
just
have to
add both of these
add both
probabilities,
of
right?
them. Yeah, just add both. So
Right?
basically, it will be like I can go about this. Let's say it is spam, probability of spam, so this remains there 0.01, and it is marked as not spam, so that will be 0.05, correct?
Mm.
So that is 0.01 into 0.05, and the rest of this term will remain as it is. It is not spam, but it is marked as spam, so the summation of those two will be the answer.
Okay. Thank you.
Yeah.
And can we 1 minus probability of spam? Can we do that?
See, probability of spam means how many mails. If you receive 100 mails, one mail will be spam. So that is not relating to your classification or your filtering system. So as I said, there are two parts to this. First part is the mail itself which is coming, whether it is spam or not spam, and once it comes in, whether your system marks it as spam or not spam. So if you just take 1 minus 1 minus p of spam, so that becomes 0.99. So that would be incorrect.
Sir,
Yeah.
is it fine to ask about the previous assignment, although the date has been passed, just to understand a question?
Yeah, you can ask. I'm
So
not
there was a
sure.
question which
Yeah.
states that there is a 10 class classification problem.
Yeah.
And what is the maximum number of discriminant vectors that can be produced by LDA?
It's c minus 1. It should be 9.
Yeah, so I mean, how do we come with that sort of
Okay. So how do you come with that? That is, I don't think that is within the scope of this particular lecture. I mean,
okay,
within of this particular course, because that is, how can I say? So if you look at my what I taught about LDA, okay. Uh, so it's like basically, finally, as I said, as I said in the last class, that there will be, so the LDA vectors are nothing but the eigen vectors of some matrix SW inverse SB. So that particular matrix has a property that there will be only n minus 1. So if there are C classes, so there will be C minus 1 non-zero eigenvalues for that particular matrix. So which is why you will get only C minus 1 C minus 1 distinct vectors, but since linear algebra is not a part of this particular course, I don't think that is, I mean, how that C minus 1 comes is not within the course of this, is within the course of this particular course, is within the scope of this
okay,
particular course. Okay, you just know that if there are C classes, there will be C minus 1 maximum linear discriminant vectors that you can get.
okay.
Okay. Yeah.
And lastly, just wanted to, although I have asked it on discussion forum,
Yeah.
like in the final assessment that we have in the center,
Hmm.
like I got a response that we tend to get an online calculator and all,
Huh.
but are we allowed to carry sheets, or I mean, what is the way
Okay.
in the Nuttel conducts the exam? Just if you can give a brief.
Actually, I'm sorry, I can't say that because I am not actually the main TA for this course. Okay, so you can ask this to the main TAs who are assigned to this particular course. They will be from IIT Kharagpur. You can ask them in the forum, maybe. They will be able to answer this better, because we are not, I am not, or either all the PMRF candidates, we won't be there for the exam conduction also. So that is why we won't be able, we don't know about this.
Okay, okay. Thank you.
Yeah. Okay.
And sir, can you explain the precision in upcoming session?
Can I explain the
Precision in upcoming session, because it was not able to do that in for my side.
precision? I
Yes,
can
sir.
explain, if you have time I can explain it right away. Let me see.
Thank you.
Precision, did I teach in week 1? I have forgotten. Just give me a minute.
Actually, there was a question in last week.
Okay, see precise. So these are very terms which are like inspired from English language itself. Precise, precision, leave precision now. Talk about precise, being precise. So when you have said many things to be positive, okay, out of which how many of them were precisely positive? So that is the meaning of precision. It is true positives by the total number of positives that you have classified. So true positives by true positive plus false positives. So in the total number of cases you have set to be positive, in how many cases were you precisely correct? So that is the meaning of precision. Okay.
So actually, it was a Pearson correlation.
Pearson correlation, there is a formula, right? I don't remember the formula. There is a formula for some mean by some root over of standard deviation or something, I think. I've forgotten the formula, I don't have it with me right now. So Pearson correlation is just a formula of some mean calculation, some deviation from mean divided by some root over something.
Yeah, it's x summation of x minus x bar into y minus y bar upon square root of x minus x bar whole square into
Exactly,
y
exactly.
minus.
So
Yeah,
the product of the deviation from the mean divided by the root over of the standard deviations.
yes.
Yes, yes. So that is precision. That is the Pearson correlation. So those are just formulas. Those you need to memorize maybe. Okay. So if there are no more questions, then I'll close this session.
Yeah. Thank you so much for your
Thank you, sir.
question today.
Thank you, sir.
Thank you.
Sure. Thank you.
Thank you.